In this video, we're going to be looking at example 3, and we will look at both parts. So in this one, it says, show that the following are probability distribution functions. So we have, in part A, we have a function that's going to generate probabilities for us. It says the probability that x happens is going to be x squared plus 1 divided by 34. And then they tell us the values that are in our sample space. We could write it as x is equal to the set of numbers 1, 2, 3, and 4. So if I'm going to set up a table for this, so I could have my x values here, and then my possible outcome, so 1, 2, 3, and 4, and I'm just going to sub into that probability formula. The probability that x equals 1 is going to be 1 squared plus 1 over 34. So that's going to be 2 over 34. And I can reduce that in just a minute, but I'm just going to leave it like that for just a second because we want to be able to show that it is a probability distribution. It'll be easier if it's not simplified. So now if I sub in 2, I have 2 squared plus 1 over 34. So it looks like that's going to be 5 34ths. The next one's going to be 3 squared, or 9 plus 1 over 34. So that one's going to be 10 34ths. The next one's going to be 16 plus 1 over 34, or 17 34ths. Okay, so now remember that for something to be a probability distribution, if we look back here, there are two things that we have to check for. One is all the probabilities have to be between 0 and 1 inclusive, and the probabilities have to add up to 1, the probabilities of everything in the sample space. So coming back to this, all right, we can see, since I left the denominator the same, we can see that they do add up to, we have 7, 17 plus 17, so 34 34ths, which is equal to 1. And we can see that all those probabilities are between 0 and 1. So if it says show that, we need to have some kind of a comment at the end. So we can say, since all probabilities, not sure why that freezes. Let me get rid of this. So we can just say, since all probabilities are between 0 and 1, and there may be different ways that you can say that. And you might even want to put inclusive here just in case there's ever one that has a 1 or a 0. And because all probabilities add to 1, P of x is a probability distribution. Okay, so you just write a little sentence to show that. All right, for B, I don't think there's any actually like this in the homework, but it's going to come up as we continue on this topic, so I think it's good for us to see this. So we have a little more complicated formula. Again, we have the values of x being equal to 0, 1, 2, or 3. So 0, 1, 2, or 3. And then we want the probability that x occurs. So now I'm substituting 0 first in for x in those three places. So I get 3 choose 0. This goes back to something that we did in first chapter. 0.6 to the 0, and then 0.4 to the 3 minus 0, which is 3. So this one, you can work it out. 3 choose 0, if you remember, is 1. And you can go back to chapter 1. Remember that the formula for this, for n choose r, is n factorial over r factorial times n minus r factorial. So in this one, if I do 3 choose 0, I'm going to end up with 3 factorial over 0 factorial times 3 minus 0, or 3 factorial. Remember, 0 factorial is defined to be 1, so we just end up with 1 here. And then, of course, this is 1, and 0.4 cubed is 0.064. All right, for the 1, by the way, I just realized I never went back and simplified those, so if you want to go back, you can simplify these two. This will be 1/2. But coming back to this one, then the next one, I'm subbing in 1 for x, so I'm going to have 3 choose 1, and then 0.6 to the first, and 0.4 to the 3 minus 1, or squared. That one turns out to be 0.288. The next one is going to be 3 choose 2, 0.6 squared, times 0.4 to the first. You should convince yourself that that's correct. This one turns out to be 0.432. And then this one is 3 choose 3 times 0.6 cubed times 0.4 to the 0, and that turns out to be 0.216. So again, you can test those and add them up. They will add up to 1. And so if you want to say or show that it's a probability distribution, you would just say exactly the same thing that we just said just a moment ago. All these probabilities are between 0 and 1 inclusive, and they add up to 1. And so therefore, we know that this P of x is a probability distribution.